So I'll now demonstrate the Forces GPU example on Frontier using libEnsemble version 1.0. And compared to videos I've made in the past, we don't need to modify the scripts in any way between platforms. libEnsemble will run a persistent generator on the first worker. This creates simulations, and the other 8 workers will run the simulations. Each will use one GPU. So this is my setup. I've set my base directory to where I'm running. Then I loaded the Python module and the modules I needed for my application. I've also created a virtual environment on top of that, which allows me to pip install my own packages. And this directory here can be just anything that's read-writable from the compute nodes. And I have activated the environment. So now I can pip install libEnsemble. I'm also going to clone the libEnsemble repo, and this is just to get the Forces example. So now I'll go into the repo and I'll change drive to libEnsemble tests, scaling tests, Forces, and then Forces app. And then in here we have a single file, which is an MPI OpenMP code. You can use the standard OpenMP threads or the target option to offload to GPUs. And this is how you build for the GPUs on Frontier. There's also example compile lines for different systems in the build Forces file. And now I need to get a single node allocation to run interactively. And so here I have my compute node allocation on Frontier, and I'm going to SSH into this node so I can see live that I'm using the GPUs. And I'm going to run a watch every 0.1 seconds of RockMSMI. I just need to resize things a little bit here. Okay, now let's try running Forces standalone. Okay, and try running with 2 MPI ranks and let's say 200,000 particles, so you can see it. And I'll do 3 time steps. Now look up here when I run. The first 2 GPUs should be used, yep. And you can see the output also shows the GPU is being used. So now let's run through libEnsemble. So we're going to go up a directory and then go to Forces GPU. And now we can run libEnsemble. So it's going to use a random sampling generator. Each worker will get a different input, that's number of particles and seed. And each worker will run Forces. So it's, so we do Python, and now we use local comms, which is just multiprocessing. And then we're going to use 9 workers, which is 1 worker running the generator, and the other 8 will be running the Forces simulation, 1 GPU each. And so all 8 GPUs should be used. It won't be perfectly load balanced because each worker uses a different number of particles. So now we can check the output in libstats. And that shows all 8 simulations are completed. And then ensemble.log will show you things like the actual MPI run or srun lines for each simulation. And then in the ensemble directory, it has directories for every simulation, and then you clean it like this. Now, if you want to try out the variable resource version, we go to Forces GPU var resources, And in this example, we will import a generator that will request between 1 and 8 MPI ranks, 1 GPU per rank, for each forces run, based on the number of particles. So now let's run again. So we'll be doing up to 8 concurrent simulations. N workers here can be seen as the maximum workers when using variable resources. And so you can see how many GPUs were requested for each simulation here. And sometimes it may be waiting for enough resources for the next simulation, but you could add additional nodes, hence more GPUs, to accommodate the larger simulations. The built-in scheduler works over any number of nodes. And there we go. So now, if we now look at the libstats file, and just pull this over a bit, you can see that there were different numbers of resource sets, which represents the numbers of GPUs used for each simulation. And in the ensemble.log, you can see that each run has different numbers of tasks per node and a number of GPUs. So this will work on most systems without any modifications. It detects the NSINs, the NVIDIA, AMD and Intel GPUs, and if it does not get something right, you can provide platform information easily using platform specs, and you can supply a subset of these fields and any of the others will be detected. Okay, thank you for listening, and bye.